All right. Welcome to this class. Uh, Today we are going to look at a single example where we'll be making use of the Coulomb's force formula to bring about the solution to this. So we have a diagram here. I might like to sketch it so that I'll be able to add some certain things or symbols or parameters that I want. So here we have a diagram here with this as charge. I'm going to call this my charge 1. So I'll make it to be Q1 to be equal to minus 20 Coulomb charge. I'll make this one to be my let me call this one just Q, which is the same thing as plus 10C. It's covering a distance of 3 meters from here to this point. I'll call this point to be my Q2, which is the same thing as minus 16 Coulomb. All right, so from here, let me just name this to be my F1. Let me name this guy here to be my F2. That is the first F1 acting to this point and this acting to this point. So now the question we are asked here is to find the resultant force acting on the 10 Coulomb charge, and as well as finding the angle of the resultant. So here, this is the resultant we are asked to look for. So I'll label it to be just FR or just F, as the case may be. So the angle we are asked to look for is somewhere around here. So this is what we are going to be working around with. So from here, we have from the next slide, we have all right. So let's take the charge force. Force of attraction between Q and Q1. This is the first thing we are going to be working with. So we have Coulomb force to be equal to K Q Q1 divided by the distance apart, which is R. From here, if we have to substitute directly, we have FC to be equal to 9 times 10 raised to the power of 9 multiplied by, if we go back to what we have previously, you will discover that our charge Q is 10 Coulomb charge and Q1 is minus 20 Coulomb charge. So from here, we have 10 multiplied by minus 20. You don't need to include the minus because the sign is only giving us the nature of the charge that we are working with. So we have 20 here. Divide the whole thing by R squared. What is the distance between Q and Q1? Is 3 meters. So here we have 3 squared. Note that K is equal to 9.0 times 10 raised to the power of 9 Newton meter squared per coulomb squared, and it's the same thing as uh, 1 over 4 pi permittivity of free space. So always remember this. So from here, if we put the whole of this together, we are likely supposed to have, FC. Our FC could be actually the F1, since we are dealing with this. FC is 9 times 10 raised to the power of 9 multiplied by 10 multiplied by 20 divided by 3 raised to the power of squared. If you evaluate this correctly, you are supposed to have 2 times 10 raised to the power of 11 Newton. So this automatically becomes our F1. Now we take the F2. We take F2, force of attraction between Q and Q2. So here we have F2 to be equal to Q2 divided by R squared. Since we are dealing with Q2, I might decide to call this one my R2, while the first one that we actually worked with would be what? R1. So we still move back. So what is the value of this? We still have our Q to be plus 10 charge, and then Q2 becomes minus 16 charge. So we have at this point, we have F2 to be equal to 9 times 10 raised to the power of 9 multiplied by 10 coulomb charge multiplied by 16 coulomb charge, all divided by the distance between Q and Q2 from this diagram is 2 meters. We have it to be 2 meters, so we have 2 this. So F2, if you evaluate completely, you are supposed to have F2 to be 3.6 times 10 raised to the power of 11 Newton. So in summary, therefore, F1 is equal to 2 times 10 raised to the power of 11 Newton. F2 is equal to 3.6 times 10 raised to the power of 11 Newton. So this is what we have as the force of attraction between Q and Q1, force of attraction between Q and Q2. So with what we have here, we can now move on to find the resultant or the net force. Net force or resultant force, FR. First of all, we'll sketch a diagram where we can include the values for F1 and F2 that we have gotten. So from here we have this, we have this, we have the resultant coming from the center. So here we have FR, here we have F1, here we have our F2. So what is the value of F1? F1 is 2 times 10 raised to the power of 11 Newton, while F2 is 3.6 times 10 raised to the power of 11 Newton. So to get the resultant, we'll need to resolve this to form possibly a triangle. So if we close this, we are going to be having something of this nature from here. and we are going to be having something of this nature from here as well. Remember that the angle formed here is 90 degrees. Angle formed here is also what? 90 degrees. Remember, we are also looking for something around this area. So from here, we can quietly extract this right angle triangle from here. Extract this right angle triangle from here. So why this becomes our theta, here becomes what we are looking for, which is the resultant or the net force. Here is angle 90 degrees. So by writing this back, we have our F1 here, which is the same thing as 2 times 10 raised to the power of 11 Newton, while our F2, which is the one that is acting downward, is the same thing as 3.6 times 10 raised to the power of 11 Newton. So from here, to be able to get our resultant or the net force, we can possibly apply Pythagoras theorem, because this is directly a right angle triangle. This is a right angle triangle. And because we have a right angle triangle, what we need to use here is to apply Pythagoras theorem straight ahead. So applying Pythagoras theorem, which says that the square of the hypotenuse is equal to the sum of the squares of the opposite and the adjacent. So from the diagram, we have FR squared to be equal to F1 squared plus F2 all squared. So from here, we can simply say that FR is equal to the square root over F1 squared plus F2 squared. So if we substitute the values that we have previously, we are going to be having FR to be equal to the square root of 2 times 10 raised to the power of 11 all squared plus 3.6 times 10 raised to the power of 11 here all squared. So from here, if you solve this correctly, you are simply going to be having your resultant to be equal to 4.2 times 10 raised to the power of 11 Newton. So this becomes the net force or resultant force. So this is what we have here. Now, how do we get the angle of the resultant? So here we have angle of the resultant. First is, we can get it through tan theta. Remember that tan theta is equal to opposite over what? Over adjacent. So tan theta is given from this diagram. You will notice that our opposite from here is the F1, while the adjacent is the F2. So here we simply have tan theta to be equal to F1 over F2. So here we have, which is simply, what is F1? What we actually got from the previous calculation as F1 is 2 times 10 raised to the power of 11 Newton, all divided by 3.6 times 10 raised to the power of 11 Newton. So from here, if you punch your calculator correctly, you are going to be having tan theta to be equal to 0.555. So here you have taking the tan inverse, theta is equal to what? Tan inverse of 0.555, which automatically gives us 32 4.28 degrees. So this is the angle. So here, if we return this, the angle that we are going to be having from here will simply be 32.28 degrees, while the resultant automatically becomes 4.2 times 10 raised to the power of 11 Newton. So to summarize what we have just done, from this diagram, where we have this here, here becomes our F1, which is what 2 times 10 raised to the power of 11 Newton. Here becomes our F2, which is 3.6 times 10 raised to the power of 11 Newton. What we have here is the resultant or the net force, which is 4.2 times 10 raised to the power of 11. Remember that we have charge 1 to be equal to minus, our charge 1 is equal to minus 20 coulomb, while the general charge here is plus 10C, and what we have at this point was Q2 to be equal to minus 16 charge. I think that is all we have. Yes. So from the previous slide, that is all we have. So from here, I think the last thing that I need to include from here is actually the resultant, which is giving us 32.28 degrees. This is what we have. Thank you so much for watching. If you have any question to ask regarding any of regarding any of the solutions that we've gotten from here, you can simply drop it at the comment section, or reach out to me to my DM directly, where I'll be able to give you a complete guide of what we have just done. So this is what we have. Thank you so much.